So Evangelos, as Linda says, the floor is yours.
All right, all right. I hope you can hear me. Okay, well, good morning, everyone. I don't see you, I don't hear you, but that's what you get when you don't show up at the conference you're invited. So, I shouldn't complain. It's a big pity that I can't be there. I was really looking forward to be there, but I'm a victim of the new wave of Corona. So I think it is safer if I stay from my own room and do this today. So what I want to talk about today is conversational search, or in general conversational IR. It is and what I would like to do here is I would like to present a bunch of challenges that I found on the top of all the challenges that we face as in the field of IR. Challenges that come from this new, in quotes, modus operandi of an IR system. Well, it is needless to say that these dialogue systems have now emerged not only as the standard way or one of the standard ways of communicating between humans and machines, but also it is in a sense the new terrain of progress in artificial intelligence. So we've seen deep learning progressing, and computer vision was the first, let's say, application domain where deep learning was making big advances and had a big impact to the field, and still does. Slowly, this has moved towards the NLP side, and dialogue systems is one of the things that demonstrate or try to demonstrate the ability of, I think I hear some echo, but I hope it's all right with you. The ability of the system to actually communicate information to the user. Obviously, it's a variety of fields that are being working on dialogue systems, or they're being involved. Machine learning field, the NLP field, the human-computer interaction field, the speech field, the IR field. And all these fields and many others have worked in the past on dialogue systems, so they have their own starting point. For instance, the NLP field clearly looked at first at dialogues that, the ones that we call chit-chat dialogues, right? So basically more of a social type of dialogues. Something that you can see at the left-hand side of this picture, right? So here we have GPT-3, one of the big language models that tries to hold a conversation with a human. Now, all these fields, nevertheless, they start converging to something that is to intelligent agents that can combine progress from all the fields. So at the right hand side, what you can see is the Blender bot from Facebook, Meta, where now the task, once you get an utterance from the human, so once you get an input from the human, it decides whether it is worth searching for something within this input, in this particular case, the entity Dom Brandy. And, the results of the search now, the output of an information retrieval system are taken into consideration in order to generate the next utterance. Now, where do we start as IR field in these dialogue systems? So dialogues, or at least part of this, has been something that we have worked in the past. It is, to me, it is very natural that we move to this new generation of dialogue systems. So we have worked on question answering. Actually, we worked on harder question answering problems than sort of the factoid question answering that most of the NLP community works on. We worked on long answers. We worked on composite answers. We worked on lists in the past. So there are tracks that did question answering 20 years ago, 10 years ago. We worked on session search, right? So this is taken from a paper from Paul Bennett and other people in the colleagues of his, where we've seen how taking into consideration historical sessions, right? So what has the user done in the past, but also the current session can improve the performance of a retrieval system at the current, let's say, turn, right? The current query, right? So, we also worked as a field with verbose queries, right? So there was a lot of work before on the field of verbose queries. Of course, most of the work there took a very different approach than what we do today. So essentially, the early efforts were trying to reduce the verbose queries back to keywords queries, which is not something that we do exactly today. But nevertheless, it is something we have done. And so if you put session search with verbose queries, you naturally immediately have this sort of conversational passage retrieval, which is the current, let's say, TrekCast. So it goes very close to a dialogue system. It is missing the part in which the dialogue system asks questions, clarifying questions, and takes the initiative. But nevertheless, we have been already covering part of a dialogue system. So what I want to do in this talk is I want to go and walk through a number of challenges that I think current information retrieval approaches are facing, and there are challenges, and then I will deep dive in some of these challenges. And these challenges, of course, are not the only ones, are the ones I work on, and so there are plenty of others as well. So some of these challenges that we see now that we have these conversational agents that we try to build. So the first challenge is coming in modeling relevance, right? So information retrieval is all about modeling relevance. You have a set of resources. You have somehow the representation of the information need of the user. So you need to model the relationship between the two. What we see is new challenges there due to the complexity of the questions asked, right? So when you have a dialogue system, the questions are not keyword queries anymore. They are complex questions. Oftentimes they are multi-hop questions. Oftentimes they're long, very long questions that contain imprecise information. And also, if you are thinking that you have a spoken system, there are a lot of mistakes that come due to the earlier stages of the pipeline from, for example, speech to text. You also have complexity in the answers that are expected, right? So now we do have a dialogue system, so we don't show the 10 blue links, right? So we do have to provide some kind of an answer. And oftentimes the answer is not as simple as a factoid answer, so an entity. Right, so oftentimes we are required to bring up long answers that may span across multiple documents, and they need to be composed. Beyond the typical resources now and the information need in terms of the question of the user, we also have extra difficulties. One of it is the fact that we have to deal with the context. So in a dialogue, the turn of the user oftentimes refers to the information that has been already exchanged in this dialogue in the past, right? So there is a context, that's the dialogue history, the conversational history that needs to be taken into consideration. It needs to be taken into consideration in order to disambiguate the current utterance of the user. And this creates extra problems, especially when you start using state-of-the-art transformer models like BERT, right? So the transformer encoders, because you cannot encode very, very long contexts here. You know, in the past, when we used to return these 10 blue links, obviously we didn't have to deal a lot with what was contained in the web pages or the resources we were returning. So, you know, it didn't matter what kind of modalities information appears in a particular, oops. I don't know if you lost me. Something happened.
We didn't lost you. I just cut the video.
All right. Okay. Okay. So right. So now we do have to deal with these more complex resources. So there are plenty of them beyond pure text. So tabular data do appear in the resources. So we do need to make to build systems that they can reason over tabular data. Now, beyond having a system that is very passive, we need to have a system that is also quite active. So it is a system that when it doesn't know how to move forward, answering a question, because you know, the information need of the user, for example, is not clear or is not clear enough, it is able to ask clarifying questions. So we need to be able to generate clarifying questions to choose, you know, which question to ask at what time and how to use the answer of these clarifying questions. I will talk a little bit about relevance feedback later. Right, and then the next challenge. So I'm trying to in 4 slides to summarize all the challenges that I see through. The next challenge, of course, is the evaluation, and you know, it's we have built a lot of evaluation benchmarks that range from the very basic ad hoc sort of type of task, an evaluation framework. To the other extent, that is the other side of the spectrum, that is interactive evaluation. And you know, these dialogue systems, they really fit in this interactive type of evaluation. However, you know, a lot of the progress in AI has come from this standardized and essentially standalone benchmark collections, right, where the user does not need to intervene all the times, and where you can develop, optimize for them, so build machine learning algorithms on them and test as much as you can on them. And this is quite difficult to develop in the case of dialogue systems. It's quite difficult because dialogues are dynamic, and the dialogue can take a lot of different routes depending on the response of the system. So once the response of the system change, because you change your system, you cannot expect that the same dialogue will be held, right? So that creates quite a problem there. Right. So this was in the summary, the things that I would like to talk about. So I will try to dive deeper into a couple of them. So not all of them, obviously. So what we want to do is essentially to build these intelligent search agents that will be able to comprehend language. They will be able to match the language of the resources and the user in order to identify relevant resources and generate language. And we also want to have a mechanism to communicate and collaborate with users, right? So generating language, simply generating language, is not the same as collaborating or communicating, because in the communication there is also the purpose of gaining knowledge and of transferring knowledge. So this has to be taken into consideration when we develop the search engine agents. Right. So how does things work, you know, before the dialog systems, when you have a query and you want to match and to understand this query and match this query with resources, right? So I'm pretty sure you have seen this picture before. These are the all the different ways that we do dense retrieval nowadays. Obviously, we have the traditional IR methods with so that they do, so to speak, sparse retrieval. So they do more of lexical match and term weighting. We have dense retrieval these days. We also have a lot of people working on sparsifying dense retrieval, or joining the two approaches and the gains you get from the two approaches. But one of the most typical ways nowadays is this leftmost figure. You can see where a query is considered. It is encoded into a final dense vector. Documents are encoded separately into final dense vectors. They are indexed in some spatial indexes, all right, where you can run k-nearest neighbors on. So then once you have a query and you get a vector of the query, you can send the query against, you can run the query against this index that it doesn't look like inverted index anymore. And you can get a set of documents that are the k-nearest documents, k-nearest vectors of to the query vector, right? So basically, you have, in principle, you have two encoders and a matching function at the top, right? So this is one of the typical ways to do dense retrieval these days, because it allows you to encode the document separately from the query, and so you can build an index that can hold the documents, and you can have a very quick retrieval. The third paradigm here over here is the classical BERT, where the query and the document, they're coming in the both as input to a BERT encoder, right, to the encoder of a transformer. And now you have all these cross attentions between all the keywords of the query against all the keywords of the document, and you can learn representations now of each one of these keywords, of each one of these tokens in the context of all the other tokens. And you can also have a special token that holds, let's say, the similarity between the two, or it is trained to hold the similarity between the two. So what is typically happening is that we use a pipeline approach. So by the way, this one does not allow, obviously, to encode separately the document from the query, and therefore it's a much more expensive way to do retrieval, because in principle you have to test all the documents against the query to find the best, right? So typically we have this pipeline approach, where at the first stage of ranking we use this, what is called dual encoder. All right, so we have two encoders. This is the cheap approach that is effective, but not as effective as the cross encoder. And then later on, we use the cross attentions in the for a re-ranker, and we get the results. Right, and this kind of approach have shown amazing results. Now we have, as I said, there are a lot of challenges on this. So one of the first challenges I talked about is these complex questions, right? So if we take this kind of question, what was the nickname of Judy Louis' father? Here, there is no resource that you can find that can answer this question. And the reason is that there is a two-hop, let's say, inference that you need to do on these kind of questions, right? So first you need to find who is the father of this person, so Clark Gable. And then once you have the answer for this sub question, you can answer the final question that becomes, what was the nickname of Clark Gable, right? So now this it is a much harder retrieval to do, and it requires smart ways of doing it, because the very, let's say, vanilla way of doing it, which is like you encode the question as it is, you get a bunch of results, and then together these results with the question again are re-encoded in order to get the final result. It's rather expensive. It's very expensive, and it's really hard to train models to actually do this kind of inferences. Another complexity, as I was mentioning, is the fact that now we get these verbose and very imprecise questions. So we built a new collection on tip of my tongue, sort of collection where people try to retrieve things that they remember from the past, right? But they can't exactly remember the name of them, right? So, for example, here, someone watched a movie when he was 4, and now he has some memories of this movie, expressing these memories, but oftentimes these memories are also false, right? So now you get this kind of questions when you have a spoken dialogue system, which is quite different than the type of questions, the type of pure and not noisy questions that we have been used to work on. Similarly, similar type of, let's say, imprecision is imprecision that comes due to mistakes in the question. And here I'm showing you typos in the questions, but a couple of slides later, I will also show you mistakes that happen due to speech-to-text imprecisions. Right. So what do we see here is, what we looked at 2 collections, the natural questions collection and the MS Marco collections, 2 collections that are very, very popular these days. And we only looked at passage retrieval, right? So not how good we are at answering the final question, but how good we are at retrieving resources. Right, so you can see, let's focus on the MS Marco, for example, and you can see here how well we do. Let's take, for example, a recall at 50. So whether we are able to find the answer in the top 50 documents, to find the passage that contains the answer in the top 50 documents when we do not have typos, and how much the performance drops when we introduce typos. Right, so we see here a humongous drop. Now you get the same kind of obviously you get the same kind of challenges when you have a spoken question answering system. I will go into that in a second. Before, I would like to show you how we attempted to solve this problem. So what we did is, the first simple things to do is to do data augmentation. Okay, so basically, what does it mean, data augmentation? It means that you take the original training data, and for some of these utterances, you replace them with utterances that contain typos. Right. So now, if we look at the recall at 50, here is the 73% of recall that we obtain without the data augmentation. With the data augmentation, we lose a little bit of performance in the data set that does not have typos, but we gain a lot of performance in the data set that contains, in the test set that contains typos, right? So data augmentation seems to work. Can we do better? So what we have done is we combine data augmentation. We combine data augmentation also with a triplet loss, where we say that, we have queries that do not have typos and queries that have typos. So we can try to make the queries that do not have typos similar to the queries that have typos, right? So if you have a query, 2 versions of a query, one that does not have a typo, the other that has a typo, what we try to do is we try to make the representation as similar as possible to each other. So we can do data augmentation, we can do this triplet loss on the top of data augmentation, and this is what gives us the best performance. It was interesting to see what can a model learn in terms of representation, right? So if you have a question that contains a typo, right? What does the model actually do with that, right? So you remember that we are in this this kind of scenario here, where the query is encoded, right? And the document is encoded into dense vector. And so now you can imagine that one of the, or more of these tokens have a typo, right? So the question was, what can we actually learn? Does it, if we do the data augmentation, if we do the triplet loss, what can the encoder really learn, or how does it become more robust to deal with these typos? So we looked a little bit at two things. Oops. So one thing was we looked at when this, so our hypothesis was that the encoder actually learns to simply ignore the word with a typo, because it's quite difficult actually to learn the correct word, right? So imagine even in the triplet loss, where we try to make the representation of the typed query similar to the representation of the non-typed query, it is quite difficult to think that the model is able to correct a particular token in this general representation. So what we looked at is how much the performance is affected when we have typos, and we classified the typos on the basis of their importance in terms of the other words in the query, right? So if you have a very significant word in the query, let's say an entity, that would be somewhere at the right-hand side situation that the importance is between 0.6 and 0.7. And if you have a stop word, then the importance of the stop word will be at the very left side of this plot, right? So here we have the recall at 50 for different typed words of different significance. And what we see here is we have this green color, which is the original model after we simply delete the word with a typo, right? So we remove it, because that was our hypothesis. Our hypothesis is that with data augmentation and the contrastive learning, the model simply learns to delete the typed word. What we see is that this is not the case. We see that indeed the model learns something about the tokens, the underlying typed token, which is interesting. Now we have the same problem with the spoken question answering, and over here, I'm going to jump exactly over here. What we have done is, like, we have taken original questions, we have put them in a text-to-speech system, then we put them back into speech-to-text system, and we got the result of it, right? So mistakes on spoken question answering obviously are very different. Well, not very different, but they have different characteristics than mistakes when you do keyboard typos, right? Typically, for example, the typed word is a legitimate word. It exists in a dictionary. Well, I don't know about this, but in general, it exists in a dictionary. And so what we see here is that if we obviously we have done this for the two collections, the MS Marco test development set and the natural question test set, in order to be able to see the results of it. And what we have seen is, again, a dramatic drop in the performance, right? So if we go to MS Marco again and we look at recall at 50, right, from 74 now, it drops to 35, which is actually worse than the typo that we see before, which was around 43. Right, so we have an even larger drop. Now, what is interesting here is that if we augment the training set with typed data, okay, we said that this is obviously of different characteristics, we do gain performance, but we can gain even more performance if we augment with data that are built through a spoken system. Now, the problem here is that you cannot have this kind of setup where you have text-to-speech and speech-to-text for all kinds of languages and all kinds of accents. It's quite difficult. So what we did is we looked at how the performance, right? So we had this low performance, how the performance improves when we do augmentation with text-to-speech mistakes, right? Against a synthetic data set like the one we created here, versus a situation where we have 4 people that they speak English with very different accents, So I think we have a French person, an Indian person, an Italian person, and a Greek person. And you can see that in the, when you have strong accent from these countries, the synthetic data, the augmentation with the synthetic data does not help much, right? So we have to find a different way to deal with this kind of mistakes in the questions. Right, more challenges here. Here we have the challenge of complex answers, where again, you have a question, but there is no single document that answers this question. So it's not only that the answer is long, like why are sunsets red, right? So if you ask why are sunsets red, then you can easily find a passage that answers this question. In this case, how can different animals perceive different colors? The answer contains a bunch of different animals and the way they perceive different colors, and there is no such composite answer in a resource document, right? So what you need to do is you need to find evidence that spans multiple articles, and within these articles, you need to combine this evidence to a final collection. So there is some work done here in building such a collection. There is this popular collection called LE5. However, the way it is built does not guarantee that the answers, the human answers, are actually based on these questions. And it is not guaranteed, the fact that it is not guaranteed that there is really evidence in the documents in order to reproduce the human answer has led to very interesting problems here. So one of them is the fact that if you try to produce an answer giving using predicted relevant passages, you may do worse than replacing these predicted relevant passages with random passages, meaning that if your input is garbage, you may actually do much better in answering a question by using the knowledge in quotes that the parametric language model has gained through the general training. Right, so we have done some effort here to develop collections that can allow to study this kind of problems. Now, I want to cover one more thing, and then I think I should stop somewhere there. So I will not go through all these challenges. So one other thing that we do, and we do a lot, is taking into consideration the conversational history, right? So if you look at a series of questions by the user in a conversational context, you will see that questions, they actually oftentimes are ambiguous if you look at them in isolation. So they always refer back to the history of the conversation, right? So there is a need to resolve this sort of anaphoras, right? When was the album released makes no sense if you don't look at the questions and the answers given above, right? So we have done quite some work to develop systems that they can resolve these questions. Okay, so this is a pretty simple way to do it over here, where we build a classifier that tells us, which words we should retain throughout the conversation, and essentially then we do a query expansion in the last query in order to gain performance and essentially resolve the ambiguity in the question. Now, how do we train? That's interesting, right? Because there isn't really a collection that tells you that really tells you that when was the album released should be actually replaced by when was the first album of the Southsea band released. So there isn't any really big collection, human developed collection that has questions and their resolved counterparts. There is automatically built collections like that, through template-based approaches, which, to some extent, make it quite ineffective to train the models. So one of the challenges that we're looking at is to develop zero-shot approaches in this problem. So approaches that they can pick up these reference words, but they don't need to be trained. Right. Now, one of the last things that I would like to talk about, and I will stop, is this ability of the system to also ask clarifying questions, right? So beyond the ability of an intelligent agent to be responsive to any questions from the user, we also want to build intelligent agents that they can ask clarifying questions. So the way we view the problem is, so a lot of people have worked on this, not a lot, several people have worked on this. Some people worked on selecting clarifying questions. So essentially they assume that there is a repository of clarifying questions that humans build. Okay, and then the problem becomes, how do you select the best clarifying question? Others try to generate clarifying questions. There is some work, for example, from Hamed Zamani when he was at Bing, that they used reformulations and session search from the logs in order to find nice and good clarifying questions to ask given a particular query. In our case, we do not work on the log, but we have, for example, we have textual data like web pages, and we want to be able to generate clarifying questions. The way we worked on this problem is we thought that clarifying questions should be about attributes or entities that a particular piece of text talks about. So if you look at this is the, let's say, the Amazon web page of an iPhone, right? And here it describes the iPhone, right? So if you look at the entities, you can see a lot of entities here that have to do with this iPhone, right? The fact that the producer is Apple, that has been tested by Amazon, that it comes with different companies, it has this guarantee, etc., etc., etc. So we thought one good way of generating these clarifying questions is actually to ask questions on entities or on types of entities, right? So if we want, if a user types in the question mobile phone, then we can ask a question about the manufacturer, right? Do you want a mobile phone from Apple? Or, which brand would you like to purchase, right? So now we are creating a huge repository of questions around entities, and the way to choose them is by finding these entities that essentially, once you, let's assume that the query of the user is, I want to buy a mobile phone, then you have a probability distribution against all the web pages, right? So you have a probability of relevance for each one of these web pages. So you have essentially a probabilistic space there. We want to find that question that can split this probability mass into two halves, right? So it's like binary search, but in not in a uniform fashion, but in a probabilistic fashion. So we train the system to find these questions, these clarifying questions that can perform binary search. Now, this is not a solved problem, so obviously, generating clarifying questions remains an open problem. How do you, how can you generate discriminative questions, and then how do you use these discriminative questions to essentially to rank articles? The last thing that I would like to talk, and that is the evaluation, is the last part. So I've skipped a lot of the several other challenges we have been working on for the sake of time. So as I said, we have been developing a lot of different benchmarking exercises, right? We have done that is very system oriented, so ad hoc search, web search, right, to very user oriented. So we had these living labs at some point, interactive search track at some point, and somewhere here we try to simulate some sort of dialogue system. For now, the conversational search track, the track cast, for instance, up to last year, it was focusing on a passive role for the system, where the system had to respond to a sequence of questions. I saw that this year they are trying to incorporate clarifying questions, so they give the ability of the system to develop clarifying questions. So we have to see how this will look. But definitely there is a gap here between the system-oriented and the user-oriented evaluation paradigms in order to allow us to benchmark these dialogue systems. The NLP community has developed a multitude of metrics that none of them really fit the problem. So a lot of them depend on really replicating a dialogue that two humans had. That simply is not the right way. So you bias the system to really follow this particular route of action, and even when it doesn't make sense because the system responded something else. The metrics are also not proper. So the NLP community uses machine translation metrics, but really the space in machine translation is so much more limited given an input sequence, what the output should be compared to this kind of dialogue system. So we don't have metrics really. So we don't have good ways to develop data sets and benchmark. We don't have good ways to measure performance. There has been some interesting attempts to develop better metrics, but I think this is a completely open question, also from the IR side of the world, to develop good metrics and good benchmarking for this. We have done some work on this, try to identify different costs in this sort of dialogue system, different ways to measure gain, to measure cost. I mean, which is a typical way to develop IR systems, which I'm not going to go much into details today. With that, I would like to stop, and these are all the students, and now there are not any more students. Half of them are in the industry, some at the academia, and some they're still working with me. But I would like to thank them, and I would like to thank you all for listening to me. I'm happy to take any questions.
Thank you very much, Evangelos, for your talk. Very interesting talk, giving the wide range of avenues of research and providing a lot of knowledge about the area. So the time is for question and discussion. If you have any question. Question. Okay. Hello? No. Je sais pas ce qui se passe. No, maybe no microphone. No microphone. Yeah. Or the computer will go to you. Hello, can you hear me?
Yes, I can hear you.
Okay. So thank you. I was wondering about, I think it was 28 slide. When you do query expansion for successive questions, so you say that you choose the words with the attention, and how do you do exactly the query expansion? Do you generate a new question or just add the words?
No.
You compare?
We just So I think later on, two of the students, they compare two approaches. So we actually did both. One was a pure query expansion. So you just add the keywords at the end. The other one used the generative model and created a new query, a new question. And interestingly enough, the keyword expansion works slightly better. Not huge difference though, but slightly better than the generative approach. But we have tried both. Any other questions? Or I don't know if there is a follow-up on this.
Okay. I have a question about the issue of complex question whose answers span over multiple passages. This opens for me maybe avenues of research in explainable information retrieval. What do you think of the pending issue about letting or designing information retrieval systems that are able to provide answers as well as explanations of answers, especially for long form answers?
Right.
What is the progress in this area? What are the pending issues? What is your opinion about that?
Right. Okay. So I have not done much work on explainability. There is one thing that I didn't cover. I have some slides on it, which has to do with controllability, which is a little bit different than explainability. But sometimes they go hand in hand. So overall, in general, I think there are a couple of efforts towards explaining the results of retrieval. There are different ways to do that. There is, for example, giving counterfactual examples. There are plenty of ways. I think recently we have seen also an effort that I really like personally, that of sparsifying dense retrieval. So, you know, turning the dense vector into a sparse vector, and essentially that means that you convert the dense query into query terms, a series of query terms, so that at least the user knows what kind of terms the user has, the system has used in order to do the retrieval. There is in next week's CGIAR, there is a call, there is a position paper, I think led by Filip Radlinski, there's also good people there. I think Christian Balog is there, where they do call for this kind of explainability and controllability, where the system not only retrieves, but also gives a natural language explanation of what it retrieves. It also gives a natural language explanation of what it thinks of the user, so the user profile. So basically the two components that are needed for the matching. And we have seen this already happening in recommender systems. So we have seen recommender systems and work under critiquing recommender systems where a recommendation is happening, a natural language explanation is given. So for example, we recommended you this movie because it contains, because Jude Law plays in it, and you also like romantic comedy, where the user can act upon it, can say, no, I don't like romantic comedy, and this is taken as an input to produce another kind of recommendation. So I think there is a lot of work that needs to be done there, both regarding explainability and regarding controllability. Obviously, when you start having generative models, from our side is a bit simpler because we know what we retrieve. But when you start using generative models to produce these long answers, then it becomes quite difficult to understand how much of it comes from the retrieved content versus the parameters of the model. This was the probing that the paper by Google, this hurdles in long-form question, in progressing long-form question answering, was making the point that even if you give random input to the system, random input in terms of retrieved documents, so the question and random retrieved documents, you will get a reasonable answer, right? So then where does this answer come from? We don't really know. So people develop this sort of more, or incorporate copying mechanisms and trying to ensure that you do the generative model actually does compose the retrieve passages, right? So that would be rather satisfying regarding explainability. Is this the way to go, or shall we create big generative models that in the hyperparameters they store a lot of information? That I don't know. I mean, but I think research in explainability in both directions is taking place, and we should be open in both ways. It was a long answer. I'm not sure if it is if it is to the point.
Okay, thank you very much, Evangelos. It was very interesting. Is there another question? Okay. Yes.
Hello. I
Hi.
have a question about data augmentation.
Yeah.
If I well understood, you had noisy data. When it is written question, it's with typo, and when it is oral data, it is with error that are found with the speech recognition phase. I wonder how you manage to check that the answers do not contain typo or errors in the generation of the answer.
Yes. So in that we didn't. So we consider that So we consider that the answers are not noisy. The answers are coming from a normal corpus, so there are no typos there. And we only played with the side of the question there. There is also plenty of work that looks at the typo resources. For example, there is a lot of work, not a lot, but there is work that they try to retrieve OCR documents. So when you have OCR, typically the typos or the mistakes are from the side of the document collection. So we have not looked at that side at all. For now, we assume that the documents are untyped, they're all correct, and it is the questions that they come with typos. So we only augmented the questions. I don't know if this answers the question.
Okay. Thank you. Is there any last question to end the session? Okay, another question.
Morning, hi. Thank you for your great talk. I would like to know something more about your belief updating model, how it works, and is it supposed to represent what the agent knows, or what the agent believes about what the user knows? So how it works?
Yes, so in principle, it should be able to do a couple of things. One thing, it should be able to retain memory, right? So users have conversations with these agents, and these conversations may be across long sessions, maybe even across different sessions, right? So you talk to an agent yesterday and you talk to that agent today. So one of the things that they need to do is they need to retain some memory. Now, this already is hard. and it is an unsolved problem still, and different people try different things. So the work from Facebook retains all the conversation, and at every utterance it searches back. So it does a search against the conversation itself. Our work, which I didn't present, for example, maintains a personal knowledge graph. We also do work with sparse attentions that you can attend the whole history, but really sparsely. Okay, so this is definitely one thing, the memory of what has been said, which to some extent represents the state of the user, and needs to be retained. The second thing that needs to be retained is a uncertainty of the current need of the user. So how much uncertain the agent is regarding what the user wants at this stage. And this uncertainty becomes narrower using the conversation history, but it still needs to be maintained, because this uncertainty is the one that helps you decide whether you should clarify what the user wants, or you should already attempt to give a response. So this is the second thing. So this uncertainty essentially is on the representation of on the understanding of what the user wants against your collection, right? So it's not simply understanding the language itself of the user. Maybe the language is pretty straightforward. It doesn't have anaphoras, it doesn't have anything, but the entropy, so to speak, of the probability of relevance is high. So it's kind of, you don't know exactly which documents the user will want. In which case, if you want to, if we take the case of product search, for example, which is simpler, like to think about, you have a query and you really can't figure out whether a particular product has much higher chance than another product. So the probability of relevance looks uniform, as uniform as right. So that's a second thing you need to do, and obviously you also need to generate. So that's a third thing.
Well, thank you very much, Evangelos, for your very interesting talk and for the discussion. So let's end the session and clap all day. Thank you very much.
Thank you also, and have a great time there. I'm really sorry I could not be there. It's already half the experience. I can't see you even, but enjoy.
And thank you very much for being here while you have the COVID. Thank you very much.
Bye.
So now it's time for break. So the break is there, but you shouldn't drink here. So you should take your drink outside. So you take whatever you want and you go out, please.
Sorry,
Pardon.
The second point I would like to point out for the following session, please move and withdraw your key.
So everything is on the machine already.
Everything already? Okay,
Yeah.
I don't know.
Sorry.
Because the share of the session.
But the share, yeah.
The share for the next session is not Celia? No, it's the following one. Okay. The share is.
Share is. Bon, je vais le trouver. Hein. Merci.
Juan Manuel Fernandez Luna.
Il est là-bas. Alors, je ne sais pas, mais vous êtes... c'est sur Mac?
Oui, on m'avait envoyé un mail ce matin.
Yann?
Là, oui.
Mais Yann, vous me les avez envoyés par mail, je les ai récupérés.
Ah, vous les avez récupérés, super.
Ah oui.
J'étais pas sûr. Ah, vous êtes multitâche.
Moi, oui.
Merci.
Je pense que je vais prendre mon PC parce que je vais avec le démon, ça sera plus simple. Et donc, c'est un câble VGA. On a un adaptateur aussi, il faut me demander c'est quand que tu...
Ah oui, pour. Pardon. Excusez-moi, hein, je.
Parce que éventuellement, on va peut-être du son aussi. Normalement, il y a l'adaptateur. D'accord. Pour le son, c'est un peu comme
Je pense qu'en fin de matinée, là, si tu veux bien, on va refaire des tests. Ouais, super. Donc voilà, à la fin, si tu veux bien rester, je vais voir avec la personne du technique si on peut refaire des
super.
Parce que là, bon, du coup, on a fait cette méthode parce que bon, on a plus le temps de faire autre chose, donc c'est parti comme ça. Mais, ok, bon, ça fait. Ouais, merci. Donc, moi, je suis là et là de ne pas remettre mon petit machin. Bon, je ne vais pas le faire pendant la pause, mais je vais le faire.
Bon, on s'est débrouillé.
On s'est débrouillé, merci. Ouais. Alors,
Je me demandais la question si c'était pas possible de sortir le son de celui-là la prochaine fois.
mais oui, moi je crois que je vais sortir le son de celui-là et peut-être même mettre mon petit machin. Hein.
Parce que là, en fait, aussi, le son il était vachement bas. Donc là-bas, et on était là.
Ah ouais, d'accord.
C'est pour ça qu'il
Et c'est
fallait
pour
mettre ça à fond.
voilà, qu'il faut mettre ça à fond.
Alors, on va refaire des. Bon,
Est-ce qu'on le teste?
donc, c'est court, hein, là, la pause.
On n'a
non
pas le temps.
Combien elle est la pause?
Je pense que c'est 15 minutes.
C'est ça, là
Ouais.
15 minutes.
Donc, on peut garder.
Non, il y a demi-heure. Hein.
demi-heure.
Enfin, elle était
Non,
marquée
ça, c'est-
demi-heure, mais
Mais on est déjà à
On est
11 heures
déjà.
là.
10h30.
10h30.
Ouais, un
Donc,
quart
il
d'heure,
nous
on
reste
peut prendre
15
un peu.
Oui, parce que normalement, là, le son de là-bas finit plus fort, mais en fait, là, ici, on était complètement.
Bon, alors d'abord, je regarde si j'ai tous mes trucs pour ma session 1. Mais restez.
Oui,
Donc, j'ai le programme 1,
Elle a froid.
le
En
papier.
plus, c'est vrai.
Et, oui, on ne peut pas la remonter un peu, cette pile, non?
Sinon, je l'éteins.
J'avais prévu.
Non, mais je peux l'éteindre, par contre. Comme
Oui,
ça,
on peut l'éteindre un peu, hein, parce que. Et le P3, ça c'est P2, donc il faut que je récupère Yann. Juste, je fais ça, comme ça j'ai tous mes papiers de toute la session, et après on peut.
Avec ça.
Alors, je ne sais pas, soit je les fais présenter avec le mien.
Non, mais je crois qu'il faut toujours présenter avec ça, mais pour le son, tout sur ça. Ça marche.
Parce que s'il doit faire le son, ça veut dire que le PC doit être devant eux et il y aura le retour.
Oui, mais s'il utilise le micro qu'on entend par là,
Ah, mais ça, on n'a pas fixé.
oui, mais le micro, il est là.
Ce que
En
je veux
fait,
dire, c'est que.
même si cette machine-là, elle est
Bonjour.
loin,
Alors, non. Alors,
il
si
parle.
vous, ok.
Moi, c'est Josiane Montoya.
Ça
Oui,
sort
toi, tu
entre
veux
les
qu'il
deux.
a ce micro
Ouais.
et ça.
Avec plaisir, avec plaisir.
Mais YouTube, c'est pas à partir d'ici que
Je sais pas.
Si, je partage sur YouTube à partir de là.
donc si c'est mieux si on,
Donc,
même
il
s'il n'y a
faudrait
pas de
qu'ils
zoom
aient
là,
le micro et le PC.
mais le micro, c'est juste on ne peut pas mettre un truc pour l'accrocher juste comme ça et dès qu'il parle
Ah, il
ici,
avait dit qu'il y avait un trépied.
dès qu'il parle, ils ne sont pas obligés de tenir le micro.
Donc, le micro serait là, mais il serait assis.
Mais ils peuvent marcher, je pense.
Ouais,
Je
debout.
pense que ils ne sont pas obligés de parler proche parce que je pense que c'est assez fort et on peut entendre les voix d'ici.
Moi, je n'ai pas tout écouté, parce que autrefois, j'étais plus multitâche, en même temps, je deviens, en vieillissant, là, j'ai un peu plus de mal.
Et de toute façon, le micro de celui-là ne marche pas.
Ah, pardon.
C'est ça, j'ai l'impression que c'est le micro
Ouais,
de celui-là
donc,
qui ne marche pas. Donc, en fait, il faudrait que je fasse l'inverse. Hein. Que je mette celui-là pour la
Mais
présentation.
en fait, je me demandais si ce micro-là, si on l'accrochait comme ça et que la personne parle, on entend toujours par les baffles, non?
Ah
Ou
oui
il faut être très proche comme ça pour pouvoir être.
Non, celui-là
Non, celui-là.
Celui-là, ouais, il faut être un peu proche, mais bon, après, moi, je peux augmenter le gamme, mais plus on augmente le gamme, plus ça va faire.
Du travail. Enfin,
Pas du travail, non,
du-
des
non, je veux dire
interférences.
des interférences. Ouais. Et si je fais l'inverse, c'est-à-dire que celui-là, c'est celui que je laisse ici.
On peut
Parce
essayer, là.
Alors,
Parce que maintenant, il n'y a plus de présentation de personnes qui vont venir.
Qui vont être à
en
distance.
ligne.
si, il y a à nouveau, sur cette session, j'ai des gens qui sont en physique et des gens qui sont à distance.
Et ils vont aussi présenter à distance.
Alors, soit je passe la vidéo et ils sont là que pour les questions.
D'accord.
J'ai 2 vidéos.
Déjà, là, on les entendra mieux parler. Le son sera plus fort quand eux, ils vont parler, parce que là,
Parce qu'on a
c'était
augmenté le
là,
volume.
c'était à 18.
Ah oui, ouais, c'était le
Déjà,
problème
on
de ça.
avait parlé. Après, c'est quand ils posent des questions, voilà.
C'est
que les gens, ils
l'interférence,
puissent
ouais.
entendre.
Oui, c'est
À
juste
midi,
ça.
est-ce qu'on peut refaire, parce que là, j'ai peur que ce soit un peu
Oui,
juste
non,
pour
midi,
faire
il y a
des
pas de
tests. On peut essayer de refaire des tests demain.
Oui, oui.
Ouais. Ce qui aurait intéressant, c'est qu'il n'y a que Zoom ici.
Ouais.
Et c'est ici qu'il sort le son et tout ça. Et pendant la présentation, on laisse l'ordi ici. Comme ça, quand ils parlent, même s'ils utilisent ça, bah, ils entendent quand même, ceux qui sont à distance.
Mais c'est-à-dire ça partir par l'ordinateur sans haut-parleur.
On ne peut pas brancher ça par ça, en fait. C'est ça aussi le problème.
Ça, on peut,
Bon, on peut l'essayer. Hein.
Il doit y avoir une prise.
Alors moi, il faut mon adaptateur.
Il doit y avoir une prise.
Attends.
Si, là, t'as une prise. Elle est là, la prise.
Ah d'accord.
Voilà.